In this video, we're going to review a couple derivative rules as well as looking at the rules for derivatives for the logarithmic and exponential functions. First of all, finding the derivative of this 7x times sine of 5x squared, please recognize that it is a product. We got the function 7x multiplied by the function sine of 5x squared. Sometimes, especially as you're starting, it's helpful to maybe kind of organize yourself and say, okay, the first function was 7x, and its derivative is 7. The second function is the sine of 5x squared, and its derivative is cosine of 5x squared multiplied by 10x using chain rule. Well, product rule says we do the first function multiplied by the derivative of the second, so dy dx equals, let's see, 70x squared multiplied by cosine of 5x squared. Right, if I multiply 7x, multiply that with 10x. And then I do the second function multiplied by derivative of the first function. And that's it. This is our derivative. We're all done. So, like I said, sometimes with product rule, especially once you start throwing the other rules in, throwing chain rule, it helps to organize yourself like this way. And you can always just do something that helps you to see it, but the first times derivative of the second plus the second times derivative of the first. Okay? I'm going to do the same thing on this second one here. I'm going to make this my first. I'm going to make this my second, so x, its derivative is 1. The other function is, I'm going to write with an exponent, x squared minus 4 to the 1/2. So the derivative is 1/2 x squared minus 4 to the negative 1/2 multiplied by 2x. Because of chain rule, the derivative of x squared minus 4. Let me clean that just a little bit, if I can. We've got 1/2 multiplied by 2x. Well, that's just x. And the x squared minus 4 to the negative 1/2 we can put in the denominator. Okay, so this is our derivative of the second. So as I write this, I do first multiplied by derivative of the second. Well, x multiplied by x over x, the square of x squared minus 4, that becomes x squared over the square root of x squared minus 4. Okay, because we multiply, of course, x into this, so it's just multiplied by the numerator. Then we do the second function times derivative of the first, so it's just that. Now I'm going to stop there, but I just wanted to also point out you certainly could get a common denominator, multiplying this second part of the function by square root of x squared minus 4, get the common denominator, and of course that will clean this up quite a bit because you're multiplying by the square root of x squared minus 4, so the square root is gone. But I'm going to stop there in the interest of time. And we've got one implicit example. Again, let me just show here the product rule. Okay, we've got that. So we've got first multiplied by derivative of the second. Well, the derivative of y squared is 2y dy dx. Okay, plus the second multiplied by derivative of the first, which is 18x squared. From there, derivative of 8x is 8. Derivative of 9y is 9 dy dx. Okay. I might make a pass through here to just maybe simplify some things. 6x cubed multiplied by 2y becomes 12x cubed y dy dx plus 18 x squared y squared. The other side will stay exactly the same. So we start moving things. Let me move the dy dx stuff this way. Let me move the non-dy dx stuff this way. So I'm going to have 12x cubed y dy dx minus 9 dy dx equals 8 minus 18x squared y squared. I'll factor a dy dx out. 12x cubed y minus 9 left. Divide both sides. And there is my derivative. Now for this, we're going to look at the derivatives of the logarithmic and exponential functions. You should be looking along with your derivative sheet, you know, the rules. You do need to memorize the rule for natural log. You do need to memorize the rule for e. The rest you don't need to memorize. So let me just start this first one. I'm going to put all my derivatives will be handwritten, of course. Okay, just in the, you know, I didn't actually define any of the functions with y's, but they're all dy dx. So the derivative of natural log is 1 over whatever is inside of natural log. So the derivative is going to be 1 over 5x squared. And then we multiply it by the derivative of 5x squared, which is 10x. Well, 10x divided by 5x squared reduces to 2 divided by x. So this is our derivative. Next, we have a product. Okay, we've got 2t. We've got e to the t, so we do our first multiplied by derivative of the second, and the derivative of e to the t is e to the t, plus the second multiplied by derivative of the first, and of course derivative of 2t is just 2. This is our derivative. So these are the two you really got to know. You got to know natural log. It's always going to be 1 over whatever this is multiplied by the derivative of that. And the other one is e, that e is its own derivative. Now coming down here, we have e to a function. Well, the derivative is going to be e to that same function, but then we're going to multiply, because of chain rule, by the derivative of that function, which will be 3 plus 2x. So there's our derivative. Next, 5 to the x plus 1. Well, we look at our sheet. You don't need to memorize this one. The derivative is simply 5 to the x multiplied by the natural log of 5, the base. Of course, the derivative of 1 is 0, so this is our derivative. Let me skip the x to the square root of 2 for a minute. I'll come back to it. The log base 4 of 4x, we start with 1 over 4x multiplied by the natural log of 4, and then multiplied by the derivative of 4x, because of course this is going to need chain rule. So the derivative of 4x is 4. Well, 4 divided by 4 is 1. So the final answer is just 1 over x natural log 4. And again, this is not one you need to memorize, so you could just look along on your sheet for that one. Now, x to the square root of 2, this one throws people, and I do this purposely because it certainly looks like you're going to be using one of the rules that you learned today. But here we have x raised to a number. It's no different than x squared or x cubed. It just looks uglier. So the derivative is simply bring the square root down, bring the power down, and then reduce the power by 1. And that's our derivative.